Okay, year 13. We should have had a go at this Unit 3 Pure Maths Task 1. So the 5 topics we had: inverse function, binomial expansion, a geometric series or sequence, a composite functions, and arithmetic sequences. Okay, so those are the 5 topics we had. So you should have had a go at these, and then you should have used either no support or a certain level of support here. So let's remember that if you're using like level 1 or level 2, you just need to have a go at a couple more exam questions, recap, and you'll probably be okay. If you get to like level 3 or 4 where you need help or assistance from someone, then there's probably quite a bit of work you need to do. So make sure you go completely back over your notes. Okay, you completely have a go at the exercise you've been given in class again, and then you go on to some exam questions like from Maths DIY or Maths and Physics Tutor. Okay, so let's get into the questions. So the first one we had was an inverse function. So I've got my function here. The function of t is x squared minus 6x plus 5. Now, looking at this in the first place may not stand out to you as being able to do inverse because it's not a one-to-one function. However, they do have a restricted domain, okay? So the domain has to be that x is bigger than or equal to 5, which means, okay, this is only going to be a one-to-one function for this domain. So if I want to find the inverse, t to the minus 1 has to be the inverse. So the first thing I do is let y equal my function. Now, if I want to find the inverse of a quadratic like this, you need to do completing the square first, okay, to be able to rearrange it. Because you'll notice you need to have it as x as the subject. Now, there's no other way of doing it apart from doing completing the square. So I'm going to do completing the square from year 12 work. So that's x minus 3, so it's half that number. Take away the square of this, which gives me minus 9 plus 5. And I'm just going to tidy that up. Okay, so I've done completing the square, and now I'm going to rearrange. So I'm going to firstly add 4 over, so y plus 4. Then I need to get rid of the squared, so I'm going to square root this side. Now remember, if we square something, we'll get plus or minus. Now we'll deal with that right at the end and decide which one we want. And I'm going to add 3. So I've got plus or minus the root of y plus 4 and add 3. Remember, you can't add 3 onto that 4 inside the root because the 3 is not part of that root. So it's that all rooted and then add 3 afterwards. Now, I need to decide, before I do my inverse part, if I want plus or minus. Now, I know that the domain of f is greater than or equal to 5. So 5, if we wrote it as our bracket, up to infinity. Which means this should also be the range, sorry, I should use t, not f. This should also be the range of my inverse. Okay? So that means coming out of this that I've got down here, okay, I should get bigger than or equal to 5. So I need positive numbers coming out. Okay? Now, to get positive numbers coming out, okay, I'm going to need my root to be positive, okay, because I'm going to add 3, that's fine, but I need to be bigger than 5. So I need to get positive numbers out of this. So that means I take the positive version. So when I write my inverse, so t to the minus 1 of x, first of all, I'm going to replace them all with x's. So I've got x plus 4 in my root, and I want the positive version of it, plus 3, okay? So that should be my answer here. Now, sometimes you want the positive version, sometimes you want the negative. Look at what the range is for your function, your inverse. Okay, that's what's going to tell you whether you want it to be positive or negative. Do you want big numbers to come out, or do you want negative numbers to come out? Okay, so next one. Okay, we got a bit of binomial expansion now. There's a couple of things that we need to do with this one. Now, it hasn't said to put what it's valid for, but that's always part of the question, so we'll do that at the end. Now, it wants to be the expanded. So the first bracket, nothing I can really do with that. Hasn't got power in it. I'll deal with that at the end. This second bracket I need to expand. So let's look at that separately. Now the issue with this is the fact that it's not in the format like we want it. So it's not 1 plus x to the power of n. Okay, so that means I need to factorize something else. So I'm going to take out a 9. And if I take out a 9, I need to divide everything by 9. So if I do 3 divided by 9, that's a third. So I get x over 3. And then minus a half. That means I'm also going to put this to minus a half. Okay, 9 to the minus half is a third. And I'm also going to start expanding this bracket. Okay, so I'm going to use my formula. So it's 1 plus nx, so minus a half x, which in my case is x over 3. Okay, plus, and then minus a half, minus 1, all over 2 factorial, times by x over 3 cubed. Oh, sorry, squared, not cubed. Plus dot dot dot. Again, remember we did the plus dot 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 because my terms don't end there. I'm just stopping it. Okay, so I'm going to tidy everything up inside the bracket first. So I've got 1. This is going to give me minus x over 6. This is going to be, if I type all this in my calculator, is going to give me positive x squared over 24. And again, I'm going to just times by a third now. So I've got a third minus x over 18 plus x squared over 72 plus dot dot dot. So that's the first, that's that second bracket expanded. And then now I'm going to go back into the other one. So now I'm going to go again. Look, I'm trying to make things flow as much as I possibly can. So I've now got 1 minus a half x times by this that I've got here. So a third minus x over 18 plus x squared over 72. Now, when I'm expanding this, I only want to include terms up to x squares. So I got to think about what happens when I expand this. So first of all, I'm going to times 1 by everything in this second bracket. So that should give me something nice to start with. So that's a third minus x over 18 plus x squared over 72. Okay, the next one we'll do is I'm going to do minus a half times everything. Okay, so minus a half times the first one, so minus a half times the third is going to give me minus x over 6. Okay, minus a half times the second one. It's basically going to make a positive, okay, because I've got negative, 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 and I'm going to get x squared over 36. Now, I'm not going to times the last two. Okay, so I'm not going to times this like this thing, because if I do it, it's going to give me an x cubed, which I don't want. Okay, so I don't need to do that bit. Okay, from here, I'm just going to tidy things up. So I've got a third, then I'm going to put my x's together. So I've got minus an 18th and minus a 6th. That's going to be minus 2x over 9 if I type in my calculator. Then I've got x squared over 72 plus x squared over 36. That's going to be positive x squared over 24, again, if I type in my calculator. Now, it hasn't asked me for this, but I'm going to do this. I'm going to do valid for, okay, mod of x, which in my case was x over 3 that I used, okay, being less than or equal to 1. And then that means that x, mod of x, must be less than or equal to 3. Okay, so I did my expansion first, then I times by the other bracket, and I just slowly tied it up again. I should have plus dot 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 there. Okay, so the next one then, we got a geometric series. Now, it hasn't in this actual question, although I'm telling you that's the topic, okay, we need to spot what actually is happening here. Now, I've got a car depreciates in value by 15% per annum. Its price when new is 20,000. Okay, so if it's depreciating, okay, let's remember if we lose multipliers, that should be 0.85 that I'm timesing by every time. So that means if I've got this, I've got A is equal to 20,000. And I've got R is equal to 0.85. Okay, I'm not adding the same, adding or subtracting the same amount. Okay, I'm decreasing it by 15%. That's going to change year on year on year. So part A, write down the value of the car after 5 years. Now this is the awkward bit because people then go, okay, that means I want the 5th term. Well, no, you don't, because you got the initial amount. Then you've got year 1 where it's been decreased. Then you've got year 2 when it's been decreased, and so on. So actually, the 5 years is actually the 6th term. Okay, so I've got 20,000, if I'm using my formula, times by R 0.85 to the n minus 1, so the term minus 1, is going to be over to the power of 5. I'm going to type in my calculator, gives me £8,874.11 it's going to be worth. Okay, now we could just use our normal like GCSE kind of like understanding of what depreciating value is and things like that. That would also work fine. So find the value when it's less than 4,000. Okay, so I don't know my n here. So I'm going to try and form something here. So I've got 20. What I would have done is I would have done 20,000 times 0.85 to some power, and I want that to be less than 4,000. Okay. So I'm slowly going to rearrange it. Let's divide by 20,000. So I get 0.85 to the n being less than 0.2, and I'm going to use my logs here, okay? So my base stays on the same side, so I've got log of base 0.85, 0.2 comes over this side, and the n goes over here. So I need n being bigger. If I type that in, I get 9.9. Okay, so find when the value is less than 4,000. It's 9.9 years. Okay, realistically, it's per annum that this is happening, so I need to round it to the nearest whole years. Okay, so I've got the value will be less than 4,000 after 10 years if I round it. Okay, 9 years wouldn't be enough, it'd still be more than 10,000. 10 years is when it goes under that. Okay, so next one. We've got composite functions. So I've got two functions here. I've got f of x and g of x defined by here. So f of x is x squared minus 2. G of x is 1 minus 2 over x. And again, they've got their domains here. So first one's for all real numbers. That would be minus infinity up to infinity. Okay, this is all the numbers but 0. So it's kind of like this, but just not the 0 bit in the middle. Okay, so we can write that as a union. So part A, I need to write down the range of f. Okay, so if I'm thinking about what f is a quadratic. Okay, so it should be a u, and it's going to cross at minus 2. Okay, so its range is its y value. So the range of f, okay, because I've got that x squared, I'm not just going to plug my numbers in. Okay, I've got to think about what that graph looks like. So it's going to go down to minus 2, and it can equal it all the way up to infinity. So that's my range of f. Now part B. Okay, I've got two parts. The first one I want to do is f of g of x. So this is putting g into f. Okay, so I've got firstly the f, which is x squared. So I'm going to replace the x with g. So that's 1 minus 2 over x squared minus 2. And I'm going to expand that bracket and solve it as much as I possibly can. Okay, now there's a few things I could do. I could expand it. Okay, what I'm going to do first is I'm going to make it a single fraction. Okay, I'm going to try and make these as single fractions because that's what it wants me to do. Okay, and I'm going to do that at the beginning. So this is the same as me having x minus 2 all over x. Okay, now I've got that by going, if I do a little bit of rough working over here so you can see what I've done. 1 minus 2 over x. That's the same as me doing x over x minus 2 over x. Okay, this is still 1, this first term, and then they have the same denominator, so I can just subtract the top. Now, I'm now going to square the top and bottom. Okay, so if I square the top, I get x minus 2 squared all over x squared. I've got minus 2. Now I'm going to use the same rule again. This would be the same as me times the top and bottom by x squared. So I'm also going to expand this double bracket. So I've got x squared minus 4x plus 4. Lets me expand that double bracket. This fraction here, I'm going to change so it's minus 2 over x squared all over x squared like that. Okay, that's the same thing. So I've got minus 2 over x squared. If I change it to that, I can put them all over the same amount. Now again, I'm just going to simplify the top a little bit here. So I've got x squared minus 2x squared. Okay, now I'm going to put my positive number first, which makes it a little bit easier. X squared take away 2x squared is minus x squared. And minus 4x all over x squared. Okay, now you may have, okay, expanded it first and then try to make it a full fraction, but you should have something that looks like this as your final fraction. You should have x squared on the bottom, and you should have these 3 terms on the top. You may have them written in a different order, but you should have those 3 terms on the top. Okay, now the next one's the other way around. So I want g of f of x. So part 2 on g of f of x. Again, I want is a single fraction, so that's subbing f into g. So I've got 1 minus, and I've got 2 over, and then I'm going to replace the x, so x squared minus 2. Now again, I'm going to use that same rule again. That's the same as me putting this as x squared minus 2 all over x squared, and then take away another 2 all over x squared minus 2. Okay, I'm just using the fact that 1 is the same as me just having the same on the top and the bottom. Now I can tie this up. I get x squared minus 4 all over x squared minus 2. Now, I could leave it as that. Okay, there's nothing really I can do. Some of you may have factorized the top and realized this difference of two squares. That's x plus 2, x minus 2. You can't simplify these two because this is an x squared, not just an x. So be careful when you're trying to simplify things. Don't force it for no reason. Right, part B wants me to solve this. Okay, so what I'm going to do, I'm first going to make them equal each other. So x squared minus 2 is 1 minus 2 over x. Okay, now I'm going to get rid of the fraction. I'm going to times everything by x. So I get x cubed minus 2x and then x minus 2. Let's take everything onto one side. So I've got x cubed minus 3x minus 2 is 0. Oh, sorry, plus 2 is 0. Okay, so from here, okay, I need to think about factorizing and solving this equation. Now I could go just into my calculator and type it. However, I'm going to do it what we should have done from Unit 2, sorry, from Unit 1 last year. I'm going to look at how I could have used maybe polynomials and things like that. Okay, that's all this is. So I'm going to look at my function. Let's call it h of x. I've already got 2. So I've got x cubed minus 3x plus 2. Okay, and I'm going to basically try and find a factor. Okay, so if I sub in 1 into my equation, I get 0, which means, therefore, x minus 1 is a factor. That's one of my brackets. Okay, so I've got x minus 1, and I should have some sort of quadratic. So ax squared plus bx plus c, and that should equal my cubic, sorry, not my quadratic. Now I can compare coefficients. If I compare the coefficients of x squared, of x cubed, a should be 1. That's nice and easy. If I compare the constants, minus 1 times what gives me a positive 2. So c must be minus 2. And if I compare the coefficients of x, I need to make them equal minus 3. So to make x here, I'll do x times c, so that's just c. And then the other one would be minus 1 times b, so minus b should equal minus 3. Now I know this is minus 2, so minus 2 minus b is minus 3. Okay, I'm going to solve this, so I get b must be 1. Okay. Now from here, I can put that back into that quadratic and I can solve it. So if I put it back into my quadratic, I've now got x minus 1 is one bracket, and my quadratic, which is x squared plus an x, and then minus 2. Okay, so I'm going to factorize this second bracket now. Remember, all this equals 0. So I've got x minus 1. Then if I factorize this one, this thing is going to be a positive negative. The only way to make 2 is being 2, so it's going to have to be a positive 2 and a negative 1. Then you notice I've got two brackets that are the same, so I'm going to get two answers out of this. So I get x is 1, and I get x is minus 2. Now, if you use your calculator, you should have got the same answer. Okay, I've just done it the longer way. We should be able to do this way, especially, again, look at marks. If this was worth maybe a couple of marks, then we could have just gone straight to my calculator. If this was worth like 5 marks or something like that, or 4 marks, then we would be expected to do this work over here and find the factors. Okay, so the final question we got an arithmetic series. Now, it does actually tell me in this, so I got, because it says the word arithmetic series. So I've got the polygon has 10 sides, the length of 10 sides, starting from shortest, form an arithmetic series. The perimeter is 675. So if I got the perimeter, that is adding up all the sides. That's the sum of the 10 sides is 675. Okay. So I can use that in a moment. And then it says the length of the longest is twice that of the shortest. So the shorter side should be the first term, which is just a. Okay. The longest should be the last term, which would be the 10th term in this case, which would be a plus 9d. What they're saying is that this a plus 9d is 2 times the short side, so 2a. Okay, and if I rearrange this, I've got a is equal to 9d. So I can use that and I can just substitute it in. And if I use the first bit, I'm going to use the fact that my sum of 10 is, if I use my formula, I've got 10 over 2a, which I don't know, so 2a plus n minus 1, so 9d, is equal to 675. Okay, now that's 5, so I'm going to divide the other side by 5 and get rid of it. So I've got 2a plus 9d is equal to 135. Okay, and what I'm going to do is I'm going to substitute, so I'm going to sub 1, let's call this number 2, into 2. Okay, so I've got 2a, 9d is just a, so plus a is 135. So that's 3a is 135. So a must be whatever 135 divided by 3 is. Okay, it gives me 45. So my first term is 45. Okay, I can then use the second one to find my d. Okay, so d must be that divided by 9, so d must be 5. And there's my two answers. Okay, it says find the length of the shorter side. So therefore, shorter side is just a, so that should be 45. Okay, now if I wanted the longer side, I could type it in. So that would be 45 plus 9 times 5, which is 90. Okay, which is true from what they said. The fact is twice the shortest length. Okay, so make sure you've marked those. Okay, and make sure you remember which level of support you've got to, and recap the topics that you need to now. Okay, but apart from that, I'll see you in the final video for Unit 4.